Hello, we are going to be looking at section 5.1, Systems of Linear Equations, an Introduction. So we've already looked at some systems way back in section 2.5, but these only consisted of two variables, primarily x and y. We did discuss a couple of ways to solve those systems. However, what we're going to be doing now is looking at larger systems, and because they're larger, we're going to be taking a systematic approach to solving them. And we'll begin to actually look at that in section 5.2. And that will be based on the Gauss-Jordan elimination method. Very exciting stuff. We, of course, will also be looking at the application of these systems of linear equations as well. So a linear equation really could be any equation that contains a variable x, let's say, to the first power. That's the key. Every variable is going to be to the first power. You can have really a whole lot of these terms being added together, these linear terms being added together, and then being set equal to some constant. That's what makes a linear equation. So in our class, we want to be able to work with the linear equations that wait a second, what? I'm not sure how that got in there. Okay, anyway, so like I was saying, what we want to be able to do in our class is handle systems of this type, which will eventually be called a 2 by 3 matrix, and then of this larger type, which will eventually be called a 1, 2, 3 by 4 size matrix. We may explore these, but I wouldn't worry about solving anything this large on any test. All right, so the first thing we're going to do is look at how to set up a system of linear equations based upon application, based upon a word problem. So let's take a look at this first example. I'll give you a moment to read that. All right, so again, what we're trying to do here is just formulate a system of linear equations based upon this given information. All right, so we know that the Johnson farm has 500 total acres of land to cultivate corn and wheat. All right. We know the cost to cultivate corn and wheat would be $42 for corn and $30 per wheat. And we also know how much money is available for cultivating these crops. So let's look at the question. Let's make sure we're homing in on the question. And even though we're not going to solve this particular system, we want to make sure we are defining our variables correctly and basing that off of the question that we're looking at. So if he wishes to use all the allotted land in his entire budget for cultivating these two crops, how many acres of each crop should he plant? So what we're going to do is we're going to let x be equal to the number of acres of corn, and we're going to let y be equal to the number of acres of wheat. You want to make sure you always define your variables if it is an application type problem. All right, now let's go back and skim through the pertinent, and let's go back and skim through here so we can determine what information is pertinent, all right, to setting up this system of linear equations. So I'm seeing that 500 acres of land is available for corn and wheat. And so since x is the number of acres of corn and y is the number of acres total of wheat, we could add those together and set that equal to 500 based on the given information. And the second equation is going to be based on the cost of cultivating the corn and wheat. So it says in the given information that it cost $42 to cultivate each acre of corn. And it also says it costs $30 to cultivate each acre of wheat. And we know the available amount of money to do this is $18,600. I'm going to put my open braces here to represent that this is happening simultaneously, to represent that it is a system of linear equations, and we're finished with example number 1.